Hey, what's up? I'm Austin Griffith, and I'm talking about minimum viable payment channels. So, it happens to be a good coincidence that I'm in LA, so I'll have that in the background. And the coincidence would be that SpankChain probably pioneered a minimum viable payment channel. So let's just run through what that means. So we won't use the SpankChain model, we'll use more of a Gitcoin model, and the Gitcoin model is you have a student that's coming in that wants to rap about some problem like this Python issue that they're having, or maybe they just want some mentorship around something, right? So they will say they want to pay like X amount per minute of ETH to some upper bound, and then a teacher will come along and say, okay, I agree to that. So that all happens off chain, and then the student will open up a session. Then the student opens up a session using an ephemeral key pair that also adds an ephemeral key pair, so you have like this signer. So the student can slowly send signatures to the teacher, and then eventually the teacher can submit those on-chain and collect the money. So there's an open and then there's a close. And that's basically the two transactions that have to happen to make this work. So let's just play around with this in the front end a little bit. So the student is this yellow guy and the teacher is this purple guy. So let's just say the student opens up a session with 0.5 ETH, and it's going to go for maybe a minute and a half, right? So that's one transaction on chain, and the channel is open. Whoops. So now we've got the student and the teacher in the channel, and the student starts sending signatures. So those signatures will slowly flow from the student to the teacher as they work through the problem over a video session. And as long as the teacher gets their money turned in or their signature turned in within this timeout, everything should work fine. So there goes a signature. Let's just go ahead and claim that as the teacher. So we will sign that and we will submit that on chain. And that means the teacher closed out the session and collected the money. Okay, so basically it's a way for the student to slowly send small pieces without having to pay gas for each one of those transactions. So let's open up one more session. Oh yeah, and here's the remainder too, right? So that's another thing. It's like even though you're using an upper bound and you're sending some amount to the teacher, you're going to have some leftover amount. So that's rolled into the contract too, where you can withdraw it here, but if you are using this service more often, you can kind of minimize your signature or minimize your transactions by, let's say we have a remainder of 0.3. Let's do another session for 0.5. It's going to use the remainder from the last session and the extra ETH you need for this session. So let's say like 2 days later, the student comes back in. They have another question about Ruby or something like that, right? They do all of the Web 2.0 coordination. They get set up. They open up the channel and they start working. Now, the thing is, the timeout is very important, right? The teacher needs to have like a bells and whistles like message. Like as soon as the timeout runs out, the student can pull all the money out. So the timeout is just to assure that that money stays in escrow. But let's just show what happens as that timeout runs out. The student is able to withdraw that if like no teacher comes along or something like that. And we can see that by hitting withdraw here, and we'll pull all of our money back out. So that's basically it. It's a payment channel between a student and a teacher. The student has to make one transaction, the teacher has to make one transaction. We use an ephemeral key pair to sign messages, and these messages flow 15 seconds at a time from student to teacher, and they're cryptographically backed, and you can verify them using the contract. So that's it. Happy Bow Tie Friday, my dudes. It's minimum viable payment channels.